All right, there's a third and final way that you can solve an absolute value inequality equation like this, and that's by just using pre-memorized formulas. We saw above we can graph, we can test regions, or we could just memorize formulas. So let me show you. Whenever you have an absolute value expression and it's less than, I think the easiest way for me to remember this is the picture. So if the absolute value of A is less than B, the distance from zero um, that A is less than a certain value B. So let's let B be here and here. The distance from zero has to be less than that. So it would be this, all of this region. So that A value has to be its distance is less than B, so it must be a value in this region somewhere, you know? So that's what the picture looks like. Okay, if the absolute value of a value is greater than a given value, B, so this says the distance that this value is from the origin is greater than B. So we go to B, that means that this, wherever it is, it's at a greater distance from zero than B. So it would mean it's out here or out here. So just remembering these pictures helps us to know these formulas. So whenever you have a less than absolute value expression, then it's going to look like this. You're just going to put whatever is in the absolute value between the negative A and negative B and positive B. But when you have a greater than, if the absolute value expression is greater than the value, then you have A is greater than the value or less than the negative of the value, which is just explaining these two pictures out. So let's see how this one works. Using formulas, which means these formulas right here, solve this. So first, notice both of these equations are solved with the absolute values on one side of the inequality. So I have to do that first. I add 2 here to both sides. 3 absolute value of x plus 4 greater than or equal to 7. I mean 9, sorry. We added 2 here, that the 2 canceled. We added 2 here, we got 9. So 3 times x plus 4 is greater than or equal to 9. Then I divide by 3 on both sides. Now I have something that looks very similar to this. My expression A is x plus 4, and B is 3. And notice it's just like the second equation here, where the absolute value is greater than this. So I'm looking at my answers to this equation are going to look like this, the second picture here. So what I need to do is write down exactly these expressions. So my, and it's greater or equal, but it's okay. It doesn't matter. It's going to be the same equations, but um, just the greater than or equal to symbol. So my B is 3. And the A is x plus 4. So the two resulting equations are the A, which is I'm rewriting this now. And I'm plugging in what my A and what my B are. So my A is x plus 4. So it means x plus 4 is greater than 3. And then I plug in my A, x plus 4 is less than -3. So that makes sense because this is greater than +3, which is, and then or less than a -3. So it kind of looks like this picture, second picture here. Now I just solve these. So subtract by 4 on both sides, I get x equals -1. I subtract 4 on both sides and I get x is less than 7. So there we go. This solution to this equation is, oh, I didn't write it as the equal sign. Oops, okay, we need those. I totally forgot this one. I totally forgot my inequality sign completely. Okay, hello. So we can write this, I guess we can leave this in just this notation, or we can write it in the interval notation. Let's go ahead and just practice writing this in an interval notation. It says all values greater than -1 and all values also less than 7. Oh, and this is supposed to be -7. Oops, sorry. -7, less than -7 and greater than -1. Because I'm like, wait a second, this is supposed to be in like two different regions. So, okay. So if we look at a graph that values greater than -1, so you have 0 right here, and then you have -1 right here. So this is shaded, the -1 is because it's equal to, and then it's greater, all values greater than -1 are going to be shaded. And then this one says all values less than -7, so you have -7 here. And then shaded, and then all values less than -7, so over here. Those are our two regions, so how do we write that in interval notation? We would say from this is out into -infinity, and stopping at -7. This is starting at -1, going to +infinity. So I would write this parenthesis -infinity and 7 in union with, or that means and -1. Oh, and it's a square bracket because we are including the -7 and we are including the -1. And then comma +infinity. And there we go. That's our solution. So maybe you found this one much easier, I hope. This was an example of this second type. So you have like a first type that we did not see an example of, and the second type. So you have to watch my next video to like see an example of the first type. All right. Thank you very much.